Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Lesson 5, Inscribed Angle Theorem and its applications. Okay, so here we go, Lesson 5. Opening exercise says A and C are points on a circle. A and C are points on the circle with a center O. Draw a point B on the circle so that the segment AB is a diameter. All right, so let me get a ruler and line this up with OA. Like so, and draw a segment from O over to the other side where it touches the circle. So OB, so AB is a diameter. So here's AB, diameter. Then draw the angle ABC. So then I'm going to put my ruler over here, rotate over to C, and draw a segment from B over to C. So here is angle ABC. Okay, so that was one. Done. What angle in your diagram is an inscribed angle? Well, now an inscribed angle has a vertex on the circle where the other two ends are also on the circle. So angle ABC is the inscribed angle. So angle ABC. Or you could have called it OBC. But if it's inscribed, you want to name the end that's on the circle. What angle in your diagram is a central angle? Well, that was the original angle they gave us, angle COA or angle AOC, either way. Angle AOC. What is the intercepted arc of angle ABC? So here's angle ABC, and the intercepted arc is the arc that goes like so. And the reason for that is, of course, if I extended this red line out to A, then angle ABC forms this arc. So it is the intercepted arc of angle ABC is arc AC. What is the intercepted arc of angle AOC? Well, it's the same one. It's arc AC. The measure of the inscribed angle. Okay, anyway, that was that one. We're done. Okay, the measure of the intercepted angle ACD is right here, is X degrees. And the measure of the central angle CAB is Y degrees. Okay, that's this one here. Find the measure of angle CAB in terms of X. Okay, so referring back to that previous example, if you look, let me draw some segments here to explain this. Angle CDB is an inscribed angle. Since AC is a radius, then the length of AC is equal to the length of AD because they're both radii. And then we have an isosceles triangle, so the measure of angle CDB is also X degrees. Okay? And finally, arc BC is right here. Angle CDB intercepts arc BC, but so does the central angle CAB. Okay, so angle Y intercepts BC and angle X intercepts BC, but angle Y is a central angle and angle CDB, or this angle X down here, is an inscribed angle and they intercept the same arc. Okay, so Y, find the measure of angle CAB in terms of X. So I would say the measure of angle CAB. CAB is angle Y, but in terms of X, it would equal 2X. And the reason is, if this was 40 degrees, let's just say, the intercepted arc is twice the inscribed angle's measure. So this arc BC would be 80 degrees. And central angles are equal to the intercepted arc. So angle Y would be 80 degrees. So central angle equals the intercepted arc. Inscribed angles are half the intercepted arc. So therefore, angle Y is twice angle X. So the measure of angle CAB, or angle Y, equals 2X. Okay? Okay, but if we didn't know that, we can take this triangle here, and we know that the sum of the angles of a triangle are 180 degrees. So in another way to explain this is, I don't know this angle measure here, but this is a straight line. DB is a straight line. So this angle here is 180 degrees minus Y. So the measure of angle CAD equals 180 degrees minus Y. And so then we would have X plus 180 degrees minus Y equals 180 degrees. Okay, X plus 180 minus Y equals a triangle, so it's 180 degrees. Well, if I subtract 180 from both sides and combine like terms, I get 2X. The 180s cancel, so 2X minus Y equals 0. And then if I add Y over to the other side, I get Y equals 2X. And Y is CAB. So the measure of angle CAB equals 2X. So I guess that would have been a better way to explain it, because we're trying to prove that central angles equal the intercepted arc and inscribed angles are half. Okay, page 2 brings us to example 1. A and C are points on the circle O. Okay, what is the intercepted arc of angle COA? Well, the intercepted arc is right here inside that angle. So it's arc AC. Draw a triangle AOC. What type of triangle is it and why? So now I'm going to just move this out of the way. And to draw this arc, use a ruler, of course, but I'm just going to use my straight segment program. Okay, and go like this. Okay, so there is triangle AOC. What kind of triangle is it? Well, OA is a radius, OC is a radius, and therefore they're congruent. We cannot assume that AC is equal to those, so we can't say it's equilateral, but it is definitely. An isosceles triangle. Okay, and the reason is these are both radii. So we have two sides congruent. What can you conclude about the measure of angle OCA and the measure of angle OAC? Well, they're congruent. So I'd say the measure of angle OCA equals the measure of angle OAC, because base angles of isosceles triangles are congruent. Part D says, draw a point B on the circle so that O is in the interior of the inscribed angle ABC. Draw a point B on the circle so that O is in the interior of the inscribed angle ABC. Okay. So I'll put B, I don't know, maybe here. So then when I draw this, like so, O is inside angle ABC. So draw point B on the circle so that O is in the interior of the inscribed angle ABC. So I couldn't draw it below CO. If it was extended as a diameter, I could not be below it, and I could not be over here where AO extended to be a diameter. It had to be between here roughly and, I don't have my pen. So if I extended CO over to here, let's just do that. I want to explain where you could have put it and where you can't. So if I extend this over here, if I were down here, then O would not be in my interior. And then if I extended AO over here, I would not, and I put a dot over here, O would not be in the interior. So this point B has to be between this point and this point. So it has to be on the left side of this diameter, and it has to be above this diameter. So this was the range we could have put it. Okay, let's get rid of those. All right, so that's done. What is the intercepted arc of angle ABC? Well, it is also arc AC. What do you notice about arc AC? It's the same intercepted arc as part A. Okay, and up here it said to color the intercepted arc red, and I haven't done that, so let's do that. Here's the intercepted arc here. Okay, so what do you notice about arc AC? It is the same arc that was intercepted by the central angle. Okay, page 3, G. Copy the diagram over from page 2. We still need it. And it says, let the measure of angle A, B, C be X. So this whole angle is X. Okay. Let the measure of angle A, O, C be Y. Can you prove that Y equals 2X? In other words, angle AOC equals 2 times the measure of angle ABC. The hint is to draw a diameter that contains point B. So let's go ahead and do that. So a diameter that contains B has to go through O, the center, like so. All right, so that creates a new point right here, and we'll call it D. All right, then what we're going to do is name these. So this was X. Now we're going to split it. So CBD is going to be X sub 1. And let's see, COD is going to be Y sub 1. So we're splitting the X up into 2 pieces. And this will be X sub 2, and this is Y sub 2. So this X sub 1 plus X sub 2 equals X. And Y sub 1 plus Y sub 2 equals Y. Okay, there's the starters. So we're going to say that X equals X sub 1 plus X sub 2, and Y equals Y sub 1 plus Y sub 2. All right. So by the opening exercise, let's go to it. what did we just determine in this exercise? It says in the opening exercise, what did we determine with this isosceles triangle? We determined that y equals 2x. Okay, so by the opening exercise, what we're going to say is y sub 1 equals 2 times x sub 1. Okay, and y sub 2, this angle here, AOD, is going to be 2 times AXD. The reason we can say this is because we've already done it on page 1, where we were saying that an angle formed by the diameter. So y sub 2 equals 2x sub 2. And therefore we can conclude that since y is y sub 1 plus y sub 2, then y has to equal 2x sub 1 plus 2x sub 2, and therefore x sub 1 plus x sub 2 is x, so that would equal 2x. All right, so does your conclusion support the inscribed angle theorem? And the answer is yes. Even when the center of the circle is in the interior of the inscribed angle, okay, it's in angle ABC, the measure of the inscribed angle is equal to half the measure of the central angle that intersects the same arc. I says if we combine the opening exercise and this proof, have we finished proving the inscribed angle theorem? Not quite. Okay, we have not addressed the fact that if the center is outside the inscribed angle. And so guess what example 2 is going to do? All right, so A and C are points on the circle with center O. Draw a point B on the circle so that it is in the exterior of the inscribed angle A, B, C. O is in the exterior. Well, what does that mean? Well, let me just draw real quick diameters just to explain this. Okay, so if I drew a diameter A through O to the other side, and a diameter C through O to the other side, if I pick a point over here and put B anywhere here, then O will be in the interior. So I've got to be either up over here or I've got to be down over here. Excuse me. Okay, so let's get these out of the way. And it doesn't matter where we do it, but I will put the point down here. So let's put B right here. Okay, draw point B on the circle so that O is in the exterior of the inscribed angle ABC. So now if I draw an inscribed angle from that location, let's use green. Did I choose this? Yes. A, B, C. Now you can see the interior of this angle is everything in here. O is obviously the exterior of. So O is in the exterior of ABC. So there's our diagram. What is the intercepted arc of angle ABC? Color it yellow. All right, well, hopefully you can see this. I will draw a yellow line here. It is right here. Oops. Let's go back to my pen. I'll use this yellow so it's easier to see on the screen, hopefully. So this is yellow, and there it is. It is arc. What is the intercepted arc? The intercepted arc is the minor arc AC. Let the measure of angle ABC be x, and the measure of angle AOC be y. Can you prove that y equals 2x? Hint, draw the diameter that contains point B. So now we're going to draw a diameter, and I guess I'll use black. And I'll draw a diameter that contains B. So I have to go through O, and it would hit the circle over here on this side, right here. Okay. All righty, so let's name that D. So here is diameter BD going through O, obviously. If it is a diameter, it has to. And we're going to let X1, Y1, and X2, Y2 be the measures of CBD. So now let me get rid of these X's and Y's. Move these off to the side. And I'm going to let's see, X1 be CBD. So CBD is this angle here. So I'll put X sub 1 right there. That's this angle. And X sub, and let's see, let's make Y sub 1 COD. So this is going to be Y sub 1 COD. And then ABD is going to be X sub 2 . So this whole thing is X sub 2, and AOD be Y sub 2, this whole thing. Okay, X and Y in terms of the measures would be, and in this case, X is going to equal this whole thing. So X is my ABC, by the way. Okay, so we're going to let angle ABC equal X, we already did, and angle CAOC, angle AOC equal Y. Okay, so if ABC is X, then how do I get X? Well, I take the whole thing, which is X sub 2, minus X sub 1. Okay, and if, let me erase this, and if AOC is this portion here, then it's all of this minus that. So Y is going to equal Y sub 2 minus Y sub 1. Okay, and by the opening exercise, Y sub 1 equals 2X sub 1. Okay, and Y, what is that? Y sub 2 equals 2X sub 2. Okay, so if Y sub 1 is this and Y sub 2 is this, then I can find Y. So therefore Y is going to equal Y sub 2, or 2X sub 2, minus Y sub 1, which is 2X sub 1. And therefore that is going to give me X sub 2 minus X sub 1. If I factor this out, let me bring this over here, and that will give me Y equals, if I factor out a 2 here, it's going to give me 2 times X sub 2 minus X sub 1. And X sub 2 minus X sub 1 is X, so therefore Y equals 2X. And we just have shown that Y equals 2X. Okay, page 4, part D. Does your conclusion support the inscribed angle theorem? And the answer to that is yes. Even when the center of the circle is in the exterior, so the center is not in this green angle of the inscribed angle, the measure of the inscribed angle is equal to half the measure of the central angle that intercepts the same arc. E says, have we finished proving the inscribed angle theorem? And we have shown all cases of the inscribed angle theorem, central angle version. We do have one more case to study in lesson 7, but it is okay not to mention it here. I'll get to that in 2 lessons. The last case is when the location of B is on the minor arc between A and C. Okay, number 1, exercise. Find the measure of the angle with measure x. Diagrams are not drawn to scale. So now we're going to apply that proof. So the measure of angle D is right here, and it is 25 degrees. So I will label my diagram 25 degrees. So the intercepted arc is right here. It is BC. So the intercepted arc is half of the arc measure. So if this is 25 degrees, you multiply the arc by 2. So what I would say is arc BC, if you wanted to show your work, arc BC equals 2 times 25 degrees. So the arc BC equals 50 degrees. So this is 50 degrees. And then the measure of angle BAC equals x. And the measure of angle BAC is equal to the measure of arc BC. So therefore, the measure of angle BAC, or x, equals, I guess we could just say that, x is equal to 50 degrees. So the central angle equals the intercepted arc, and the inscribed angle is half the intercepted arc. So when they're shared, the central angle is twice the intercepted arc measure. Okay, so that's the quick shortcut. So now they're giving us the measure of angle D, which is right here, 15 degrees. Okay, that tells me that the intercepted arc, because D goes up to C and angle D goes all the way over to B. And since this is 15 degrees, the arc measure is 30 degrees, and therefore this angle is 30 degrees. And we're using prior knowledge now. This is a straight angle, 180 degrees. So if BAC is 30, then CAD has to be 150 because they need to add up to 180. And now we have 150 and 15. So now we have the triangle sum theorem. Okay, but AD is a radius, AC is a radius, so base angles are congruent. So I didn't even need to do that. The measure, or x, equals 15 degrees. So there's multiple ways to have done this. I could have done this without even doing our proof that we just had, because I have a triangle with 2 sides the radius length. So therefore it's isosceles, so the base angles are congruent. So just like that, x is 15. Okay, so this one. The measure of angle BAC is 90 degrees. It's labeled for us. So this arc here is 90 degrees. And then, as you can see, the angle that's inscribed in the circle is right here. That's angle, they didn't do a very good job putting their letters here. That's a D, I think. Angle BDC is right here. This is angle BDC. And it's intercepting the same arc, so half of 90. So in this case, x equals 45 degrees. It is sharing the same arc as the central angle. Okay, and that's how you do these. Okay, next page. I forgot what page it is. 5. All right, so this time I'm going to do it a little different. I'm just going to label everything first. So I will mark my inscribed angle. Okay, what is this doing? All right. So there's my inscribed angle. And here is my central angle. All right, so as you can see, they share the intercepted arc. Okay, so the measure of angle B is 32 degrees. Here's our given. So that is right here. So if this is 32 degrees, then this is 32 times 2, which is 64 degrees, which makes this central angle 64 degrees. Okay? So remember that these blue lines are radii of the circle. So this is an isosceles triangle. So these base angles are congruent. So the triangle sum theorem says the sum of the angles equals 180 degrees. So 2x equals, subtracting 64 from 180, I get 116. And then dividing both sides by 2, I get 58. So x is 58 degrees. 58 plus 58 plus 64 should be 180. Okay. Now it says here, BD, segment BD equals segment AB. All right. So I'm going to label that. Let's use green this time. So they're saying AB is equal to BD. These two are congruent. So we have an isosceles triangle. If I extend this out to here, then I have an arc. Let's use purple. I have an intercepted arc right here, and I changed that diameter to blue by mistake. Let's put this back to green. Okay, so this arc right here is intercepting this part of the circle. This is a diameter. All right, so we have x, and then these two angles here. So this x is 1/2 this angle here. W are congruent. So this angle plus this angle, they are equal. Okay, so this one's a little tricky. Let's just label these. This is equal to that. And since this is a radius, then we have another radius here and another radius here. So what's going on here is AB is a radius, AD is a radius, AE is a radius, and AC is a radius. So we have all these isosceles triangles. Okay, and then this one here is saying, well, not just isosceles, all three sides are congruent. This is an equilateral triangle. So x equals 180 divided by 3. So x is 60 degrees. Okay, F. All right, so they're giving us a measure of angle D. Angle D goes up to C and B. So I'm going to color code this so you can see it better. Angle D is right here. Okay, and it is intercepting arc BC right there. And if you notice, there's a central angle. A central angle. AC goes to here, so angle CAB shares that arc BC. So what does that mean? It means that the measure angle BAC is twice the measure angle BDC. So that's what we're going to use to solve this. And we were given the measure of angle D is 19 degrees. So this is 38 degrees. So therefore this angle here is 38 degrees. And AB and AC are radii, so they are congruent. I have an isosceles triangle. So the base angles are both the same, and our vertex angle is 38 degrees, and the triangle sum theorem says that all three angles add up to 180, so I get 2x equals, subtracting 38 from the other side is 142, and then dividing by 2, I get 71 degrees. So that is the measure of x, 71 degrees. Okay. Number 2, Toby says that triangle BEA is a right triangle. Okay, so let's label that. I'll make it red and let's make it thinner. So triangle BEA is right here. Okay, and Toby is saying that that's a right triangle. And it's asking if he is correct. So measure of angle A is 70 degrees. So if I extended this out here, then that would make this arc 70 degrees. And that would make this angle down here half, or 35 degrees. And the Triangle Sum Theorem says that this angle here, which is vertical to this angle, so if this is 90, this has to be 90. So then I would say, okay, well, if that's the case, since these are vertical angles, angle BEA is congruent to angle DEC because they're vertical. So if I assume that that is 90 degrees, like Toby says, then this is 90 degrees. So then I'd say, okay, well, let's do the Triangle Sum Theorem and check this. And 90 plus 50 plus 35, therefore must equal 180 degrees. And that should be over there, but you know what I mean. So 90 plus 50 is 140, plus 35 is 175 degrees, does not equal 180 degrees. So therefore, Toby is not correct. It is actually 85 degrees. So that is not a 90-degree angle, and it is not a right triangle. Okay, and that's how you would do that one. And I went the wrong direction with my answer here. It's not 85. Okay, if I need 5 more degrees, then that angle measure has to be greater. It's got to be 95 degrees. Okay, so Toby's not correct. It's 95. Okay, page 6 brings us to number 3, and it says, let's look at relationships between inscribed angles. Examine the inscribed polygon below. Okay, it's inscribed because every vertex is on the circle. That's what makes it inscribed. It's a 4-sided figure. It's a quadrilateral. They're calling it a polygon. That's fine. Express x in terms of y and y in terms of x. Are the opposite angles in any quadrilateral inscribed in a circle supplementary? And explain. So here's what I'm going to explain. If I were to take a compass and make it red, and I will put it at the center. Where is the center of this circle? Somewhere around here. Hopefully I'm close. And let's just see how close I am. Is it staying on the circle? It's got to go to the right just a smidge and open this up a little. Let's try this. And I'll show you why I'm doing this. All right, that's pretty close to center right there. So let's make this thicker. If I were to draw an arc from here to here in red, and then change it to green and drop the same thickness. So why did it? And then draw an arc from here to here in green. So as you can see, now if I take and make an angle with x, that's green, going out to that inscribed angle, that's green, and then do the same with a red arc, or not arc, but angle out like so. Hopefully you can see that the angle y that's red is intercepting the arc here and here, and the red arc is the angle is intersecting that arc right there. The green angle x is intercepting the green arc. The red arc plus the green arc is 180 degrees times 2, or 360 degrees, a full rotation of a circle. So therefore, if a full rotation of a circle is 360 degrees and the intercepted arcs are twice the inscribed angle, then the inscribed angles have to add up to half of that 360 or 180 degrees. Hopefully that makes sense. And so now it says express x in terms of y. So x would equal 180 degrees minus y. Y would equal 180 degrees minus x. Okay, B says to examine the diagram below. How many angles have the same measure and what are their measure in terms of x degrees? So if I were to, let's just use red. Here is the angle that's x degrees. It is intercepting the arc. I wish they would give me the center for these circles so I could put my compass stylus at the center. Kind of hard to guesstimate a center. Let's try here. And I'm way off. Okay, right there. I've got to move it this way a little. Try here. And it's got to go up a little. I'm trying to find the center as close as possible so I can explain this. I want to draw. Ooh. Okay, just a little this way. That's pretty close to the center, so I'll use that. All right. So the intercepted arc is right here from C to D. Okay, that's off a little, but you get the idea. Okay, so what they're asking in this problem is how many angles have the same measure? Well, in order for those angles to have the same measure, they have to intercept that same blue arc that goes from C to D. So let me change to, I don't know, green. So I can see that B goes out to C. So if I draw a segment from C to B and a segment from D to B, you can see this green arc intercepts that blue. So angle CBD. So it says how many angles have the same measure and what are the measures in terms of x degrees? So the measure of angle CBD equals x degrees. And if I go back to my segment maker here, and I will do this one in purple, I see that the vertex F goes down to my C, and F also goes over to D. So angle CDF, angle CFD, I mean, equals x degrees, because those three angles all intercept the same arc. Okay. Angle H obviously does not intercept that arc. H goes to D and H goes to C, but it would be the supplement to angle X. And angle G goes to C and angle G goes to D, so angle CGD would be congruent to angle CHD, which would be y degrees. This is y degrees. This is x degrees, and this one is x degrees. So these three angles intercept that CHD arc, which is a minor arc, and angle CFD is the major arc formed by the supplement or the angle that's made by angle Y, which is DHC or DGC, the major arc here. So these are the two angles that are congruent to angle CED, and they, in terms of x, they're both x degrees. Okay, page 7 brings us to some application problems. So though proving stuff like on the prior pages doesn't seem very exciting or it's tedious, it is a necessary evil. If you understand those proofs, it makes this part of it much easier. And once we're done with the proofs, applying them, hopefully you understand and can apply. So here is a circle. We have an intercepted arc here, CD by angle Y. This is not a diameter. There are no diameters here, so we can't assume any congruency. There's no radii. So I have to use what I'm given. So this is X, and this is X, and this is 74, and this is 28, totaling 102 degrees. So right here is 102 degrees. Okay, just thinking this through. Okay. So knowing that is 102 degrees, if I follow it out, it goes to F. So if I draw an arc all the way around like so, let's try that again. Whoa. Okay, really difficult to do with a pen and a pad. Okay, so, but you get the idea. There's the intercepted arc from angle FDC. So if this is 102 degrees, this whole thing is twice that, or 204 degrees. 28 goes to here and here, so that is 56 degrees from F to B. Okay, this to here is 56 degrees. The whole thing is 204. So then if I subtract 204, 74 times 2 is 148. So let's erase that 204 and put 148 here. So 148 is from here to here, okay? Totaling 204. So if that's 204 degrees and I have another arc, a minor arc over here, that's 360 minus 204, which is 158 degrees. Okay. And if you look here, angle X forms this 56 degree angle. See how this goes out to B and this goes out to F, and this is 56. Half of 56 is 28 degrees. And since X has to be equal, then now this is 28 degrees. Okay, so if I have 28 and 28, which is 56, now I'm going to focus on this triangle here. And sometimes it gets a little difficult to see all this. It gets cluttered, but now we have this triangle here. And if this is 56 and this is 74, and the Triangle Sum Theorems will say that Y plus 56 plus 74 equals 180. Y plus 6 plus 4 is 10, 7 plus 12, 5 is 12, plus that 1 is 13 equals 180. Therefore, Y has to equal 50 degrees. So Y is 50 degrees, X is 28. Okay, and there's part A. So you have to put a little bit of thought into these. They're not always just direct. Okay, so what do I focus on here? Now we have an exterior angle that we haven't dealt with yet. So I'm just going to leave that alone for now. Actually, no, I can find this angle here, but does that help? I'm going to focus on a couple of things here. This angle here is 14 degrees, and that is angle FCG. So this arc right here is 28 degrees because it's twice the intercept, or it's twice the angle. The intercepted arc is 2 times the inscribed angle. So this is 28 degrees. Okay, I'm not going to do anything with this. We haven't discussed exterior angles yet. There is a theorem that will lead us to find CV, but we have not done it yet. So I have to look for other ways to figure this out. I know that these two angles are vertical. These two angles are vertical. This is an interior angle, but not central. So what else do we know? this would equal 2y degrees. So if y is here, this is 2y. So this is 28. We don't have, and then if you look here, this is 14 degrees. So that's 28. I need to find this. Okay. Okay, so now I see it. You really need to study these. Okay, so let me explain. We know this angle here is 14 degrees and it forms that 28-degree arc. But now when I look, I see that angle EBG, if you will, or FBG, shares that same intercepted arc, and therefore this is also 14 degrees because it intercepts the same arc. Okay, so that's one thing we just found. All righty, so what else? 14 degrees, 14 degrees, 34 degrees, 14. This angle here is 180 minus 34 minus 14 because of the triangle sum theorem. I'm not going to do it algebraically. I'm just saving time here. This angle right here is the angle FCE, triangle FCE. Angle EFC is the vertex angle, 34, 14. So I'm going to subtract 48 from 80, 180. So let's just do it that way. 180 minus 48, which is 34 and 14. And that would give me 7, 2, 3. So this is 132 degrees. Okay, does that help? So let me erase this 28 here. That's the arc measure. So now I have 132 degrees here. Okay. So if that's 132, then I can find this arc right here because that's a straight line and that's a straight angle. So 180 minus 132 obviously is 48 degrees. So this is 48 degrees. And if you look, that intercepts this 2y arc here, which is also y. So this 48, so 2y equals 48. So 2y equals 96, therefore y equals 48. So this is 48 degrees. Okay, that one was tricky. Okay, part C, question C. First thing I'm going to do is create an arc. We were given an angle of 40 degrees, which is an inscribed angle, okay, which goes to there. So with that being 40 degrees, the intercepted arc, let's make that green. Here's my intercepted arc right here, arc BC. The intercepted arc is twice the inscribed angle. So this is 80 degrees. All right, the key to this is we now have a central angle. Let me make this thinner, it's getting too thick. Central angle right here. Also intercepting arc BC. Central angles by definition are equal to the intercepted arc. So this angle right here, I'm going to draw it out over here, is 80 degrees. So this little angle here is 80 degrees inside this triangle. This is 112. We have a straight angle here, so this is supplementary. So 180 minus 112 is 68 degrees. So this angle here is 68 degrees. And then we'll use the triangle sum theorem to finish this. So 80 plus 68 plus x equals 180 degrees, because this angle and this angle and this angle are in this triangle A, B, and whatever this point is here. 80 plus 68 is 148 plus x equals 180. So therefore x equals 180 minus 148, which is 32 degrees. Okay, part D. Part D, let me get my blue ink. I see a central angle that's labeled with a degree measure. So I'm going to focus on that for starters. That's 120 degrees. It is intercepting arc BC, which is right this portion of the circle. Okay, if that's 120 degrees and it is a central angle, then it equals the intercepted arc. There is an inscribed angle that goes to the same endpoints, and it is right here. Okay, and therefore angle BEC intercepts arc BC. It is an inscribed angle, not a central angle. And inscribed angles are half the intercepted arc, so this is 60 degrees. Okay. So angle Y is right here. Angle Y goes out to B and out to C, and that is our other arc, which is our major arc out here. So there's 360 degrees in a circle. 360 minus 20 is 240. This is 240 degrees. Therefore, Y is half of that, or 120 degrees. So as you can see, we have a quadrilateral with opposite angles congruent. And these are radii, so those are congruent. So this is a parallelogram, and therefore these two angles are congruent. And 120 plus 120 is 240, leaving 120. So this is 60 degrees here. This is 60 degrees here. And therefore x equals 24 degrees. Or no, it does not. Let me think. These may not be congruent just because that's 24. That may not be the same angle, 24 degrees. So what else can we get from this? What am I missing? Okay, so here's what I'm going to do here. I'm going to extend this all the way out to there. Okay, and I have just created an inscribed angle right here of 24 degrees. And so therefore from here to here is twice this angle, which is 48 degrees. Okay, and sometimes you just have to keep messing around with this until you have everything filled in, and then the answer pops out. Okay, so now if I extend that one, this is x degrees, so this distance is 2x, but I'll just leave that blank for now. I don't want to confuse things. But if you look here, this is an inscribed angle of 60 degrees, and it intercepts at D and over here at this extension. So if I think of this as twice this angle right here, then this is 120 degrees. Okay. I can do the same with this 60 degree angle, which comes from here and goes all the way around to here. So this is 120 degrees. So from here to here is 240 degrees as well. So let me just erase this 240 now. We've already used that to find that 120y. And so now this piece from here all the way around to here is also 120, because 120 plus 120 plus 120 is 360. But this piece is broken up into two, 120 and 48 from this angle. So if this is 48, this piece here is 120 degrees minus 48, which is 72 degrees. So this arc right here, from this point here over to E, is 72 degrees. And that is what X is intercepting, and X is half of 72, so therefore that has to be 36 degrees. So X equals 36 degrees, Y equals 120 degrees. All right, that one was a lot more complex. All right, E. So again, always just look for inscribed angles and central angles and start with those. So I have this angle here. That's a central angle. Therefore, I will use green for the arc. It intercepts arc EC. Central angles equal their intercepted arc. So this is 60 degrees. This angle here is 50. Okay, and now if you focus on D, here's the key to this problem. D is on the circle, so it is an inscribed angle. It shares the same arc as EAC, which is a central angle, but it's an inscribed angle, so it's half of that angle. So this angle here is 30 degrees. Okay. So that's 30. This X comes down to here, but we do not know CD. This would be 2X from here to here because this arc or this angle intercepts this arc and it's twice the angle measure. All right, so this is 50. So I'm just going to do what I did on the last problem. I'm going to extend this radius out to a diameter. And now I know that from here down to here, since this is intercepted by that 50, this is 100 degrees. Okay, and if this is a straight line and this is 60 degrees, and there's 180 degrees in a straight line, 180 minus 60 is 120 degrees, and that's another central angle. So this arc here is 120 degrees. So now I have 100, 120, is that correct? We'll see. This is 60. Yeah, that's right. So this 120 plus this 60 is 180. That's half the circle. And this 100 plus over here is half the circle. And this, since I need 80 degrees, 2x equals 80 degrees. So therefore, x equals 30 degrees. And there we have it. All right, I can't divide by 2, I guess. 80 divided by 2 is not 30. 80 divided by 2 is 40 degrees, not 30. This 2x equals 80. 80 divided by 2, 40. All right, next one. All kinds of stuff going on here. So like I said, look for inscribed angles, look for central angles. I will start with this 60-degree angle here. Doesn't matter where you start, pick one. And that goes out like that. That intercepts the arc. I'll draw it in red, FC. So E is 60 degrees, FEC 60 degrees. It's an inscribed angle, so this arc is 120 degrees, the angle times 2. Okay, but this piece from here to here is formed by a central angle, and I'll still use purple, right here. So this angle here is 60 degrees. And so therefore, this piece from here, I did it in green, this piece from here to here is equal to the central angle or 60 degrees. So therefore, FB is also 60 degrees because that whole red thing is 120 degrees. And arc FC is 120. FB plus BC equals the whole thing. And they're both 60. So that's a total of 120. Got it? All right. So what are they asking for? X. So that we're done. X degrees equals, well, X is half of the intercepted arc, which is 60. So X equals 30 degrees. Okay, page 8 brings us to the end of lesson 5. Review the lesson summary, 2 theorems and 2 vocab words, and go do your problem set.